All right, today we're finding the least common multiple, and we're going to do this in a way that was much like finding the greatest common factor. So to find the least common multiple, we're going to use our factor trees again. And so we'll take our numbers and factor them down to their prime factors. So 40, I know 4 times 10 equals 40, or I could have done, I know 40 is even, so I could have divided by 2 and gotten 20, but I'm just going to do it this way. 4 is even, so I can divide it by 2. If I do that, I get 2. 2 is a prime number, so I circle it. 10 is even. I can divide it by 2. If I do, I get 5. Okay, those are primes. 50 is 5 times 10. 5 is a prime number. Circle it. 10 is not. 10's even. I can divide it by 2. I get 5. 2 and 5 are prime, so I circle them. Now, I look for the numbers that they have in common again. So actually, what's different about the least common multiple and the greatest common factor is instead of looking for matches, I'm going to look for the numbers that don't match, and I am going to list those. Okay, I'm going to do it the way that they showed you in the video, so I'm just going to write down my primes for each one. So I got 2 by 5 by 5. If I did 2 times 5, I get 10 times 5, I get 50. Okay, this one I got 2 times 2 times 2 times 5. When they did this in the video, they wrote the repeated factors with exponents. So 2 times 2 times 2 can be written as 2 to the power of 3. 5 times 5 could be 5 written to the power of 2. Now what you do is you are going to take the largest exponent version of the base. So here I have like matching 2's as bases. I'm going to keep this one for my least common multiple, 2 to the power of 3. And then I'm going to keep this one for 5 to the power of 2. And if there was one in the list that didn't match, I would write that one down here on my list. So like if this one had a factor of 3 and this one didn't, I would write that 3 down in my list too. So 2 to the power of 3, if we want to plug it into our calculator, because we're really just not sure what that is. If I can't think, 2 to the power of 3 means 2 times 2 times 2, and do 2 times 2, which is 4, times 2, which is 8. If I'm not there yet, I can put it in my calculator. I put 2 for my base. It's being slow. Being so slow, I'm skipping it. 2 to the power of 3 is 8. Times 5 to the power of 2, which is 5 times 5, which is 25. Then I do 8 times 25, and I get 200. Now I have my least common multiple for 40 and 50. So what that means is 40 will fit into 200, and 50 will fit into 200. 40 would fit into 200 5 times. 50 would fit into 200 4 times. So if you listed them out like they did in the video, you'd go 40 times 1 is 40, 40 times 2 is 80, 40 times 3 is 120, 40 times 4 is 160, 40 times 5 is 200. And then for 50, you'd go 50 times 1 is 50, 50 times 2 is 100, 50 times 3 is 150, 50 times 4 is 200. So you hit both of those numbers eventually if you are listing out your list of multiples for each of those numbers, 40 and 50. It's when you hit the same number that you stop if you're doing it the list way, but the factor tree way is just more efficient. So I got 200 for that one. And I'm going to do 25 and 60. Okay, factor them. 25 is divisible by 5 because it ends in 5. 25 divided by 5 is 5. 60 ends in 0, so it's divisible by 10. 60 divided by 10 is 6. Just a reminder, the way that you're dividing down the factor tree, you can multiply back up. So if you're like, I don't know what to divide 60 by, maybe you can think what times what is 60, like 6 times 10 is 60, and do it that way to get your branches. 10's an even. I can divide it by 2 and get 5. 6 is an even number. I can divide it by 2 and get 3. Now I'm going to write down my prime list, and I'm going to write them with exponents. So I've got 2 5s. So I'm going to write 5 to the power of 2 for this one. And for this one, I have 2 2s. So I'm going to write 2 to the power of 2 times, I only have 1 5, times, I only have 1 3. Now in this one, between these two broken down primes, the 5 squared is the biggest one for the ones that have the base of 5. So I'm going to put that in my list. 5 squared times, and then there's no other matches, so I include the 2 squared and the 3. The ones that don't match, I just include in the list automatically. So then, if I wanted to, I could put this in the calculator. Let's try this again. 5 squared equals 25 times 2 to the power of 2, or 2 squared. 2 squared is 4 times 3, and then I could put those all in my calculator. 25 times 4 would be 100, times 3 would be 300. So that is my least common multiple. So if I were counting by 25s, eventually I'd hit 300, 25, 50, 75, 100, 125, 150, 175, 200, 225, 250, 275, 300. Okay. If I counted by 60s, I would also hit 300, 60, 120, 180, 240, 300. All right. 300's our least common multiple. Okay, find the least common multiple of 12 and 30. I could do this one in my head because I know if I do the multiples of 12, 12 times 5 is 60. So if I counted by 12, 5 times, I'd hit 60. 30 times 2 is 60. So if I counted by 30s, I'd hit 60. So I'm going to skip my factor tree and just type in 60. Okay, 15 and 20. Let's go ahead and do factor trees. Just for a little bit more practice and demonstration. Okay, 15 ends in 5, so I'll divide by 5. 15 divided by 5 is 3. 5 and 3 are primes. I circle them. 20 is prime. I can divide it by 2. 20 is even, I meant to say. 20 divided by 2 is 10. And 10 is even, so I'll divide by 2 and I get 5. 2 and 5 are primes. So I list my primes. I have 2 2's here, so I'll write 2 squared. 2 times itself twice, times 5. Now on both of them, I have a 5. So I'm going to list 1, 5. They don't both have a 3. I list my 3. They don't have matching 2 squared, so I need to include that in my list. 2 squared, like I said, is 4. 2 times 2 is 4. I'll bring down the rest of my problem. Now that I've simplified that exponent, I just rewrite the rest of the problem. 5 times 3 is 15 times 4 is 60. I can do that in my head. I can count by the number I'm multiplying by, and I will count until I hit like the number of times I'm multiplying by that number while I'm counting. So I can do 15, 30, 45, 60. 15 times 4 is 60. 60 is our least common multiple. 15 goes into 64 times. 20 goes into 63 times. 20, 40, 60, 3 times. Okay, least common multiple of 12 and 15. Okay, 12 is even. I'll divide by 2. I get 6, which is even. I'll divide by 2 again. And I get 3. 15 ends in 5, so I know I can divide by 5. 15 divided by 5 is 3. Okay, write them down. Instead of writing this like 2 times 2 times 3, I'm going to use exponents. 2 to the power of 2, because I have 2 of them that I'm multiplying together, times 3 in this one. I don't have any of the same prime numbers, so I just have 5 and 3. Okay, so I look for, now in my trees that I've brought down to the primes, I look for the ones that, like the biggest ones and the ones that don't match. So I have 2 squared. I don't have that in both of them, so I need to include that in my list. I do have a 3 in both of them. I'm just going to keep one of them. If either of them had an exponent, I would keep the larger one, but they don't have that, so I just keep one of them. And then I have a 5 that is not uncommon. So again, 2 squared would be 4 times 3 would be 12 times 5 would be 60. 15 again fits into 64 times. 12 fits into 65 times. 10 and 16. 10 factors down to 2. Oh, come on, draw. 2 and 5. 5 times 2 is 10. 16 is even. I'll factor it down to 2 and 8. 8 is even, so I'll divide by 2 again. Keep circling my primes. 4 is even. Divide by 2 again. Okay, so I factored down to my primes. Drawing perfect circles. So here I've got 2 times 5 at my list. Now this one I have just a whole mess of 2's. I have 2 to the power of 4. Okay, I keep the match that is the largest with the exponents, or if they're the same, I just keep one of them. So here, out of my 2's that are my bases, I keep the 2 to the power of 4, and then the 5 doesn't exist in both of them, so I need to include that in my list. So then I go 2 to the power of 4 times 5. 2 to the power of 4 is 2 times 2 times 2 times 2, so I know that that's 16. 16 times 5 is, I think, 90. Let me double check. I'll do this all in a calculator. So let's say I'm doing this. Like I gotta go 2 to the power of 4. I get 16 times 5. And I get, 80. Whoopsie daisy. Good thing I checked. Okay, 27 and 36. I know 27 and 36 are both divisible by 9. 9 times 3 is 27. 9 times 4 is 36, so I'll start there. 3 is a prime. 9 is divisible by 3. If I divide by 3, I get 3. Again, same thing, I can kind of copy from one factor tree to another if I've already done it. I just did 9. And then 4, we know is an even number, and we'll divide it by 2 and get 2. Now we write them with exponents, so we have 3 times itself 3 times. So I write 3 to the power of 3. For this one, I have 3 times itself twice. I write 3 to the power of 2. And this one, I have 2 to the power of 2. Okay. So then I look, are there any matching bases? Yeah, these both have 3s. I'm going to keep the bigger one. So 3 to the third. And then the 2 squared, it doesn't match, so I include it in my list. Now 3 to the power of 3 is 27. 2 to the power of 2 would be 4. 27 times 4, I'll put that in my calculator, and I get 108. That's the least common multiple. All right, on to the next lesson. This one's kind of tricky, but once you memorize the steps, you'll get it. All right.